Hello, good morning. Apologies for the delay. So this will be network operation session number 2. We'll have 3 speakers this morning. We'll be starting off with Leah from RIPE MCC to talk about RIPE Atlas.
Thank you, Mark. Good morning, everybody. Last day. So, my name is Leah Estina. I'm from the RIPE NCC, and today I'm going to talk to you about RIPE Atlas, spotting latency issues with RIPE Atlas. So I wonder, how many of you have never heard about RIPE Atlas before in this room? So everyone have heard about RIPE Atlas? Everyone have used RIPE Atlas? No? Raise your hand if you haven't heard about RIPE Atlas. Good. Okay, some of you. Many of you heard about RIPE Atlas already. So let me start my presentation with a story of Dennis. Dennis has a problem. He is a network engineer, and he maintains DNS servers, and he would like to know if his DNS servers are reachable from many locations. So, and he heard about RIPE Atlas, and he's going to try RIPE Atlas. And let's see, he has some problems. So he would like to know where are the networks with high latency, and so he wants to know which are their locations. And the other thing that he would like to know is which networks have high latency. So he would like to know which service provider it is. So there are 4 requirements that he would like to know, showing latency, location, and route. And the product should also be within budget. Of course, it should be safe and secure, and it should be from a trusted source. And now let's start with the RIPE Atlas as a trustworthy data source. So RIPE Atlas is actually an internet measurement platform that consists out of thousands of vantage points. At the moment, we have more than 12,000 probes connected worldwide. And these tiny devices that we call the probes, they're hosted by volunteers. And yeah, and once this probe is connected to the internet, it will start collecting all this data, such as ping, trace routes, and the data that we collected by the RIPE NCC, it will be made publicly available. So in this picture, you see where are the distribution of the RIPE Atlas at the moment. We have around 12,000 probes connected, and because RIPE NCC is in Europe, the most density is within our own region. So here you see the probes, the latest version of the probe, which is version 5. And we have around 30,000 measurements currently running. And next to the normal probe that we also have the RIPE Atlas anchors. So RIPE Atlas anchors is actually more or less the same as the RIPE Atlas probes. It's just that it's much more powerful. And you can use RIPE Atlas anchor to run HTTP measurements. And it's available in 169 countries, as you can see. And now we can go to how can you access RIPE Atlas? There are 3 ways to access RIPE Atlas. We have a very nice user interface where you can run your own measurements, and you can see measurement results of other people that are running, and you can see internet maps. I will show you some example when you access the RIPE Atlas via the user interface. But you can also access RIPE Atlas through the API and also CLI tools. We have a very vibrant community members around RIPE Atlas, and they're creating, like, so for example, this one, Stephen Bortsmeyer, he was creating his own CLI tool, and you can read the information about this tool on RIPE Labs article that's shown there. There are 6 types of measurements that you can run with RIPE Atlas: bring, traceroute, DNS, and stuff. For the HTTP measurement, you can only use anchors as target to run your HTTP measurement. So what are the use cases? How can you use RIPE Atlas? The thing which is unique about RIPE Atlas is that you can use RIPE Atlas, or anyone can use RIPE Atlas. You can use the vantage point that RIPE Atlas has towards your own network. So right now you have more than 12,000 vantage points. You can see your network reachability from outside. So that's what makes it really special, I think. And people use RIPE Atlas to investigate and troubleshoot network issues, and test and compare IPv6 deployment and connectivity. The other thing that you can do with RIPE Atlas is check the responsiveness and the proximity of DNS infrastructure, such as root name servers. All right, so let's see what you can see with RIPE Atlas. So you need to show latencies, location, and routes, right? So this is a new prototype tool that one of our colleagues, Emil Alban, created a few months ago. And in this visualization that I'm going to show you, he would like to see, the latency he will see the minimum latency into each ASN and IXP from a specific time. As I mentioned, this is still prototype, so there's still limitation and possible solutions for these tools. So if we look at this picture, I'm using top ASN in Manila, which is 9299. That's IPG. And if you look at this picture, this is color coded, right? So the more green, the less latency it has. So here you see everything is green. It shows like approximately where this ASN is located. And if you're IPG, you might want to know if this is okay, if this picture is more or less what you expected from your network. We would like you to try this tool and give us a feedback, and see if it's also useful for you. So if you hover to the hexagon, one of the hexagon, this is showing the number of the probes there. And if you click on it, it will show you another angle of the of what we want to see here. Let's have a look if I can go there. All right. Can you click further? Oh, okay. So this is the angle from the probe ID point of view. If you host this probe, this is showing the neighborhood, the network in the neighborhood of the probe where that probe is located. So from this, you can see that if this probe is connected in network interconnection, you will see that there's a plateau. There's a flat line here, and the latency is more or less the same, right? But here, if this ASN, because this is the list of the ASNs in the neighborhood of this probe, and if this ASN are important to you, you might want to have a look at why this is having a high latency. So there's still limitations and possible solutions. For example, if there's no probe there, we can't measure, we can't show anything, of course. But have a look at this this RIPE Labs article, where you'll find all the information that you need about this MinRTT prototype tool. So now I'm going to show you some visualization of DNS measurement that I did to auth DNS ns1.idnic.net to resolve idnic.net. So here, On the left-hand side is a query A record on IPv4, and on the right-hand side, it's a query A record on IPv6. As expected, kind of, the performance on IPv4 is kind of slightly better than the IPv6, but yeah, unfortunately. So this is just to give you an idea what you can do with the UI of RIPE Atlas. And this is actually the same measurement, exactly the same measurement. So it was running from around 200 probes in Southeast Asia. And on this picture, you see something interesting. So this probe, 4788, for example, the response times is quite high on IPv4, while on IPv6, it's slightly better. That's something interesting to see, I think. And while this one, 6905, the latency in IPv4 here, it looks like there's something here happening. Maybe issue with routing or something, I don't know. Yeah, this is the same measurement, but then from world view. And here, this visualization from a world view, you can almost guess that this IP address is Anycast, right? I don't know if it's Anycast, but it could be. But if you look at this picture, yeah, kind of. I think it's Anycast, but we'll see. So the other thing that you can do with RIPE Atlas is running traceroute measurement. And in this picture, you see Tracemon tool, which is already ready at your disposal. You can just use it. It shows the hops and the routes. Oh, it didn't play. Well, actually, it's a video showing the hops that it takes, which one first and the last. So a bit of statistic. I think we have that already. RIPE Atlas anchors, we have that already. And safe and secure. RIPE Atlas is safe and secure. So some people asked me this week, is it listening to my traffic and stuff? I said no. So when someone run a measurement, it will never go directly to the probes itself. It will, the user, when they run measurement, it will go to our RIPE Atlas controller first, and then the controller will notify the probes that we have around the world to conduct this measurement. And then the probe will contact the user server and going back. So you will never see that the user go to the probe, connect to the probe directly. And further, we do security review. This review is done regularly by external people. So you can go to RIPE Atlas website if you're interested in the security of RIPE Atlas and this report. You can go to this link. So one of the things which is very unique as well about RIPE Atlas, you don't need to break a bank to use RIPE Atlas because it's almost free. As long as you host a probe, you can use, when you host a probe, you will get credits. So this is how it works. We have credit systems. This system is there to protect the platform and to avoid overload, and of course, to prevent abuse. So when you host a probe, you will get around 21,000 credits per day that you can use to run your own measurement. How can you get these credits? There are 4 ways to get credits. One of them is by RIPE Atlas user. When you create an account, you will start with around 500,000 credits to get you started. And then if you host the probe and anchors, you will also get credits. We also have the RIPE Atlas ambassadors. There are people, they're evangelists actually. Some of you are here. They're supporting us, promoting RIPE Atlas, and yeah, and they get incentive from the probes that they distributed. And we also have sponsors. Sponsors are companies, organizations that believe in the project, and they finance, they give us funding so that we can keep distributing the probes free of charge. So Dennis has used RIPE Atlas. He he saw he could see the latency from his measurement. He saw the location. He sees the route, and he knows that RIPE Atlas is safe and secure, right? And it's from trusted source. So, and finally, last but not least, he doesn't need to break a bank to be able to use this platform. And now a bit of view into the Philippines and Southeast Asia. And right now we have around 21 probes connected in the Philippines, and we have 2 anchors. So we would like to get more coverage of RIPE Atlas, because right now, as I mentioned earlier, the density is in Europe and North America. So that's why I'm here talking to you people, so that you will be interested in RIPE Atlas, and you can use RIPE Atlas as well as helping us connect RIPE Atlas probes. On this website, this is an eyeball network. If your ASN is listed here and it's still yellow or white, talk to me. Maybe you can host RIPE Atlas in these locations. You can change the country code to your own, and then you'll see if your ASN is listed here. And this is how many probes are right now connected in Southeast Asia. There's not that many. I mean, we could really use some help with deploying probes within Southeast Asia. And except for Singapore, we have a very good coverage in Singapore. And this is how it looks at the distribution in Asia Pacific. This is the same one where you can see the eyeball networks where we want to have probes, and how the density of the probes distribution. You see that all the ones in yellow, we still need some help in distributing the probes. So this is more or less why you can run your own measurement. You can detect customer issues, test any cost deployment, test IPv6 connectivity. So I hope this is enough to convince you to host a probe and use the platform. And here we have some use cases that you can read later after about how people use RIPE Atlas. And later we will have also from Barry, his experience later. And on this one, this might be interesting for you, because if you are new to RIPE Atlas, this is a podcast with Robert Kristelaki. He talked about RIPE Atlas because he was there from the very beginning until now, how it developed. So yeah. Talk to me later, host RIPE Atlas in APNIC region. It would be great to have more deployment in APNIC region. And if you host the probe already and your probe is disconnected, please reconnect it. All right, this is more or less my talk. If you have any question, do I have time for question? Is there any question? If there's no question, then thank you, everyone. Thank you for the time.
Okay. Thank you, Leah. So next up, we'll have Barry from Akamai to talk about your experiences.
Thank you. There we go. Okay, so we had somebody drop. We were talking, Leah and I were talking anyways about RIPE Atlas work. My name is Barry Green, work for Akamai right now. Having fun there. I'm a testing geek. I'm doing lots and lots of testing. I go back to, anybody ever hear the benchmark methodology working group in IETF? BMWG. This is something for if you do testing in a network, if you run a network, if you're a network engineer, if you're a systems engineer, it's work to go back and look at, because it explains how to do testing methodologies. And this is one of the things in using RIPE Atlas with it. So what I'm going to do is I'm going to give a context with one of Akamai's platforms. So Akamai, if you don't know, we're edge cloud architecture spread all over the world. We have very diverse network requirements. So this is going to be one of them that I'm going to go through and walk through. which is our authoritative DNS infrastructure. Now, here's how we apply RIPE Atlas with it. I'll kind of explain our testing methodology with it. Our authoritative infrastructure is unique. It's a hyper-resilient architecture because everything on Akamai's business is dependent on the authoritative DNS to work. It's got to work 100% of the time, all the time for any place of the world. So it's kind of got a uniqueness to it, which makes it hard for people to kind of say, well, wait a minute, how do I test this? And this is where tools like RIPE Atlas come in to help out with it, right? Because we use it quite extensively. So, and we use tools internally. We write our own tools. We use commercial tools, right? Third-party tools. We use a lot of them. Sometimes we buy the company, like Impulse, one of the tools we used to be a user, and then we decided we use it so much we might as well buy the company, right? So those things happen. Just like Thousand Eyes by Cisco, right? That sort of thing happens. And we use a lot of open source, right? So in open source testing, RUM testing, RIPE Atlas testing, things like that, because what you want to watch out for when you set up a testing architecture to make sure your network is providing the quality you need to watch for certain principles. That's why Benchmark Methodology Working Group in the late 90s, we talked about things like confirmation bias and myopic focus on testing, right? There's principles of testing that was kind of developed. So you don't go through and say, oh, I'm only using RIPE Atlas and I only see one point of view and this is what I think is broken. But then you find out after you troubleshoot for a while, the ladder was on the wrong wall. You're working on the wrong problem, right? So that's where having a thoughtful testing architecture is helpful with it. So let's talk about this platform. This gets confusing because it's an authoritative service that does anycast. And people think authoritative service does anycast. Oh, that's simple. I got servers spread out there and everybody's anycasting around. Yes, Akamai does that, but Akamai does that for each name server. So when you look at Akamai, you see any organization that uses Akamai as an authoritative DNS, you'll see like A2-64. A2 is a Anycast cloud as big as Newstar's Anycast cloud or NS1's Anycast cloud. It's huge, right? Just A2. That's just one. That's just one named server, right? And then we usually issue our customers 6, right? Because if you attack one Anycast cloud, the other 5 are up. Right. But then we push out the zones for all our customers to every single one of our 20 Anycast clouds. Right. Now, how do you test that? Right. Because it's not testing a server. Each of the name servers isn't a server. It's an Anycast cloud with it. So it gets the complexity. Now, the reason why we do that is because it can't go down, makes it really hard for attackers. We account attacks against the infrastructure, like how many attacks per second, because we got a lot of customers and a lot of miscreants out there and they attack the system. So it makes it hard. And the way you kind of work through it, there's more complexity there because this system is like the first part and you go into a mapping system. So what happens is, how do you do like a waterfall as you go from one to the next CNAME to the next CNAME, right? So this is some complexity to it. That's why you need to have a little look at the tools and make sure, in our case with RIPE Atlas, it gives a apple-to-apple comparison because you can take RIPE Atlas as a tool set, the way it's been designed from the very beginning. Watching the podcast that Leah mentioned is a good one from the source of it. From the very beginning, it's set up as a tool that gives you a lot of flexibility in constructing a testing architecture. Need to look at something. So like for this sort of thing, we can build test and then work with our customers and work with inside Akamai when we're troubleshooting the problem and kind of work through it, right? So in what you're testing and looking at, what we're trying to figure out is this complexity, because we'll put what we call a region, stack of servers, top of racks, router, a switch, stack of servers with the servers in there. This is what we call like a region. You have DNS authoritative regions, DNS resolver regions, hashing regions, MQTT regions, right? You have a whole bunch of different types of it, but all of it you kind of go through. And how do you do the test? Is it the problem a server problem? Is it a problem a load balancer inside the rack? Is the problem with the peering connection? Right? You got complexity that you have to walk through with testing this out. So this is why, like for instance, on this platform, authoritative, we have 3 core anchor tests that we run all the time. We have tests that we built. We call it Top Monitor. Right. And this is basically, it's to test an architecture. You have to think of it. What Top Monitor does is within each region, when you go, see if this goes back. Yeah. So within each region, with each of these racks, top level monitor is inside there. And what it does is like up at the top there, you know, laser pointer up at the top. This region tests this region, right? Now, some people would say, oh, that's good enough testing, but that's not testing from what our customers see. What that does is that tests the fabric of the internet, right? So this is where you design tests. You got to think of what are you testing? What are you looking at? So this particular test monitors the fabric of the internet as every single region is talking to every other region, and we're monitoring that. So it doesn't test end user. It tests what is going on with the net and making sure that over the net, each of our racks of servers can talk to each other, right? Then we use a lot of catch point for this platform. We have other platforms who use Thousand Eyes, right? We have other platforms who use Dynacast or Dynatrace, right? So we use commercial tools depending on what is the need for that particular service, right? Tune to it, right? So some people say, oh, I only use one vendor out there. Well, it depends on what you want to test. So that's why thinking through your testing methodology. And we use Ripe Atlas because Ripe Atlas, it seems like lots of people in Akamai use Ripe Atlas because it's very flexible. I can tune the Ripe Atlas test to what I'm trying to measure and construct my testing architecture around it, right? So let's give some, and the reason why with this, I kind of did this to explain to customers where you put your probes, where the different tools and different testing companies do their measurement from is important to understand where it's measuring from, right? Ripe Atlas, one of the strengths and one of the reasons why you use Ripe Atlas all the time is because Ripe Atlas ends up most of the probes are in people's houses, right? You talk to Leah, she's got a bag there of probes. You take the probe, you take it home, you plug it into your house. It's in my house. It's in my mom's old house in Tennessee. It's in my mom's place in Singapore. That's why lots of people in Singapore, they plug it into their apartments, right? You plug the probes in, and that gives a particular point of view that you can't match with Catchpoint or Thousand Eyes because it's really hard to do that, but Ripe Atlas has that strength. So you say, okay, if I'm looking for like a measure an end user performance from the home, there you go. Now, if you're trying to measure end user performance from the browser, then use something else, right? Because there you got to look at what's going on with the actual computer connections, protocols being used, things like that, right? So you use different tools for different parts of what you're trying to test for. So within Akamai, every engineer, I do this all the time. I get on with the engineering team and say, like, do you guys got a Ripe Atlas account? So number one, do you have an account? Don't ask them, do you have a probe? Do you have an account? Go sign up. I always push our field engineers, our test engineers, our support engineers, get a Ripe Atlas account, right? And then we have an internal email alias and says, once you get an account, announce to the email alias, hey, I just got an account. And then we got so many people with like, personal anchors and things like that. We send them a bunch of credits. Because one of the key things, and this is for everybody here, who here has Ripe Atlas accounts? I want to see if you raise your hands. Who has Ripe Atlas accounts? All right. All of you who don't have hands up, right now, as I'm speaking, go to Ripe Atlas and sign up. If you're a network engineer and you don't have a Ripe Atlas account, you don't have a toolbox. This is my personal. I've been doing this for years, right? And all you need to do is go out there and you sign up for the account. You sign up for the email alias and say, I'm brand new to Ripe Atlas. I just submitted to get a probe. Can somebody pass over some credits to get me started? And you get credits. And then the stuff that Leah showed and what I'm showing, you can start right away. So that's what we do. We do that within Akamai. We say that we use our credits and say, okay, you're a new field engineer or you're doing something for a customer, do Ripe Atlas, here's some credits, get started. And then the probe will come, right? And then they'll start earning credits for themselves for their own stuff, right? So that's one of the big things we encourage inside the company is to get everybody to sign up for it. And then we encourage the customers. Then what we also do is in Ripe Atlas, right? You can see right here, we have these accounts set up, right? That are our group accounts, right? So we have, like, for instance, this is a Atlas network for the network team. There's an Atlas name server for our name server team. That's like the DNS stuff, we'll use the name server. And so what we do is everybody who has an account, you can actually have automatic donations, right? So every day I donate my credits to one university, And then some of them to this network account, this account here. I donate some of my credits to here. I donate some of my credits to the name server account, right? So as you get more and more people on your team, you can actually put it into a group account. Now, the reason why you want to do that group account is then you can set up a monitoring system, right? Because we have Ripe Atlas running all the time with certain monitoring to test the quality of our network, right? So we set that up with it, right? We also write things. If you guys want to see how this works up, just email me. I'll send you this draft of this white paper. We're eventually going to push it out to our community blog on testing architecture. So you can see how we use this to do comparative and testing architectures and why we would do it and why you do it in certain ways with it. So this is an example of a testing architecture where we're using Ripe Atlas. Because what we have to do with our authoritative system is here we'll get people say like, oh, Cloudflare is faster than Akamai. I said, well, actually with authoritative DNS, depends on your point of view, right? So don't look at like the big test because it depends on where you test, right? If you test the way Cloudflare wants you to test and compare, then you say, oh, Cloudflare is faster. But if you test from the home, then, well, it all depends on where you're at and what server you connect up with, right? There's a variance in there. So this is where understanding how to do the test is important with it. So for instance, customer call up and say, hey, we don't think your name servers are fast enough for your authoritative lookups. So what do we do? So what we do is we go out there and say, here's an example. This particular customer was doing a competitive test. So they put Cloudflare and put us on side by side. So this is one of like commercial testing sort of stuff. So we set up a test, set up a simple query. The added thing on this that I didn't do, and I'll show you another slide, which is I'll run, the nice thing about Ripe Atlas is you run simultaneous test. So I'll run a DNS lookup, a trace route, and a object lookup, a web object lookup, right? And you run those in parallel. So it goes to the same probe, they kick off at the same time, and then you can actually see these comparisons of the tests. So you load it up with the API and throw it into a tool, and you can see things going on with it. That's part of the flexibility. And so you set up where you want the probes to be, right? You can select all that with the number of probes, and you get the results. And if you get a copy of these slides, you can actually see. So each of these tests over here, I tend not to take the tests that I do on Ripe Atlas and hide them. So you can select when you do a test to actually make it private or have it public. So if you when you download these slides, you can go click, 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 click. You actually see the test. So, you can see which customer it was at the time on there. It's public. Here's another example. I was troubleshooting where I was working with a customer doing a comparison. And this is where you do parallel tests where you do DNS and traceroute and an object with it. And with the traceroute, I was going like, okay, I'm running into a bottleneck here. And this, so I had one customer, they were running Amazon, Cloudflare, and Akamai, and said I was running this latency jump, right? So then I had to get in, remember the region design? There was a problem with the router for that particular region, right? And so because I ran the trace route back and forth with it, I can say like, oh, all right, open a ticket, go fix this thing. Fix things, right? So this is kind of like an example with how to do it. So in Akamai, we use this all the time. We use it operationally. We run it for monitoring. We do lots of testing with it. We use it for troubleshooting. We do comparative testing. A lot of times when a customer says, "Oh, here's my catch point test. Something's broken," we'll replicate the catch point and we'll replicate with Ripe Atlas, because it gives a comparative of it, right? So this is like operational. This is like a big company. Here's how we use it. Everybody here in this room, if you listen to this, if you don't have a Ripe Atlas account, your homework right now, go sign up for an account, right? Right there with it, right? And this is why inside Akamai, I always emphasize, with the team, don't trust other people's testing. Get the testing inside your organization. Run the test, look at the data, scratch your head, figure out what's going on, be an engineer, troubleshoot, Ripe Atlas. It's your toolkit. So, all right, that's my 2 cents. Any questions? Any comments? And remember, what you do right now while you're listening, Atlas at ripe.net. Go sign up for an account.
All right. Okay. Sorry, you've got a question.
Oh, I got a question.
Yeah.
Yes.
Sorry, morning. Mike from Globe Telecom.
Yeah, hi.
Currently in a network, we are using TWAMP as a measurement tool. Right? How this RIPE application differs from TWAMP? Will this somehow complements?
All compliments. What my experience in doing network engineering for decades is that do not fixate on one measurement tool. Like, give an example. When I was down in Indonesia at SmartFriend and Moratel, right? We deployed RIPE Atlas anchors. We deployed RIPE probes all over the place. Was that the only tool we used? No, we used a ton of different tools, right, to measure, because you had to measure different things. We're measuring RAN on the mobile network, or there's a range of different things you want to do. And RIPE Atlas, because it's an open community source, because you can get a whole bunch of your engineers on it, becomes a valuable tool to go side by side with it. And because the way the economics of it is set up is, you get probes deployed, you earn credits, and you're not putting money out of your pocket, right? Compared to other tools you're paying for, right? And so that way, when you're scratching your head and troubleshooting a problem, you say, okay, here's one tool, the tool you got right now, here's RIPE Atlas tool, and then you can look at some other tools and say, okay, what's broken? Let's go fix it.
All right.
Yeah.
Thank you.
Yeah. Oh, Philip's got a question.
No, I do not. I don't have a question. Philip Smith, Apricot. No, it's just more a comment. I mean, I've been a RIPE ambassador for the Atlas probe. I've no idea how many years. Forever it seems, and I've handed out a lot of probes around the region and so forth. And it just seems to be the age-old problem. The person they give it to is delighted, understands exactly as you presented, exactly as Leah's talked about, what's all possible. And then they change jobs or they get promoted. And then there's just this thing sitting in the network. And so many people think, oh, this box is spying on me and it's unplugged and I can't get hold of anybody. And it seems to be mostly in this part of the world. People just, I don't know. And they're missing the most fantastic measuring tool that I know, just to see how the network is. I've got one sitting in my house here. I've got one in my mum's house in Scotland, around the family, trying with friends and all the rest, just hosting these probes because it's such a viable way of finding out what the network is or isn't doing. So
this is why, as an ambassador also who, I signed up to ambassador, go down to Indonesia, I handed up all these probes and none of them got plugged in, which is why you hear what I do, like even inside Akamai. Don't hand out the probes, sign up for the account, get some credits, and then go out there and start using it and realize, this is good for me. Right. So, probably advice to the RIPE Atlas community is, have them prove that they, because probes are valuable. It costs money to send a probe out and things like that. And I see this in Akamai. You'll get like 10 people sign up and 3 of them become just like RIPE Atlas champions. They're using the test all the time. Right. The other 7 is like, they don't get tested. You want to whack them on the side of the head to get them to test. But if you send out all 10 probes, that means 7 are dead, 3 are alive, right? So it's to Philip's point with that. It's important that you get people kind of hooked as a engineer to be embracing the sort of testing you do, right?
Okay, thanks, Barry. Appreciate you stepping up today as well.
Okay. Oh, thank you.
Okay, next up, we're going to have Dave from NZlog to present on OpenLI and a practical implementation of it.
So good day. I'm Dave from Searchlight, where I'm a network consultant. And yeah, as Mark said, I'm here to talk about OpenLI, but mainly about how to put it into an ISP and make it actually function and do what you need. So I guess over the last few years, I've managed to put OpenLI into a few different ISPs around New Zealand. I'm not really officially part of the project at all, but I've kind of become the son of token figurehead of the project. The person who should have a lot of kind of limelight for this is actually Shane, who didn't manage to make it up to Manila. But Shane's sitting in the virtual audience, so he could better answer some questions later on. He's obviously very interested in this talk. So when Shane wrote OpenLI, he was working for the University of Waikato, and he still does commercial support for OpenLI via the uni. So what is Lawful Intercept, or LI? So it could be called LI, it could be called Lawful Intercept, it could be called just an intercept. In Australia, I think they call them telecommunications interceptions. I think legal intercept is normally the wrong word for it. So in New Zealand, we got a new act that came in 2013. It just said we must do interception. We all figured PCAPs are fine. Most people kind of figure that. However, 4 years later, the standards were gazetted, and kind of hidden in that sort of lot of text there is something that says the ETSI standards must be followed. That kind of caught me at least by surprise. So I did a post to the NZNOG mailing list. I got about sort of 70 private replies to that. Seems not many people are willing to admit publicly that they cannot do LI. And what that meant is enough interest to actually do a collaborative solution, hopefully a free solution to do LI in an ETSI manner. Around that time, I also started talking to the University of Waikato. Richard and Shane there had a lot of experience of writing some libraries called libtrace that was great at looking at packets and inspecting them and doing funky stuff with that. It sounded like that would be very useful in a project like this. So thus, OpenLI was born. Here's our first website. Here's our first GitHub page, the 1.0 release. So let's go on to what the software actually does. So OpenLI can carry out a data intercept or a voice intercept, or actually nowadays it can do a 3G or a 4G data intercept as well. Then it can produce that data in an ETSI standard. And that's a standard that the authorities like to digest because it actually will stand up in court and it's auditable and cannot be changed. OpenLI can actually also put out PCAPs if you need to kind of go do the old-fashioned way. Now, the ETSI standard is used extensively around Asia Pacific. It's used all around the world, especially in Europe, funnily enough. It's not used in North America, but outside of North America, you've got a good chance you'll be needing to use it. OpenLI compliance, as I said before, it's something that's sort of very auditable. It does all those things mentioned here that I mentioned before. Email interception is being written as we speak and is very close to done. And many New Zealand ISPs have actually deployed it, and we know it works. It interoperates with the authorities in the correct manner. So OpenLI's got three main components. We made it very modular. It's got a provisioner that is the centralized manager for the whole system. It's got one or more collectors, and I'll touch on why you might want more than one shortly. And they're the boxes that take packets in and does funky stuff with them and passes on to a mediator, which leads me to the mediator, which is the box that actually outputs all of the either the PCAPs or the ETSI encoded data to the law enforcement agencies. So OpenLI should be trustworthy. Like I say, there's no black boxes or hidden back doors. If you don't believe me, then read the code and you should hopefully find the same. And if not, hit up Shane. So integration. So OpenLI integrates with most of the main vendors' sort of mirroring features. So you can use Juniper FlowTap or JMirror. You can use the Nokia mirroring system. You can use the MikroTik TZSP sort of traffic sort of mirroring system. And Cisco could be coming soon if we can sort of fund the development of that. Performance, you can do multi-gig sustained intercepts. And that's using something like DPTK normally to kind of make that go at really good speeds. You can absolutely do a DIY deployment. We have packages for all major Linux distros. There's also Docker containers that you can use. There's tutorials, YouTube tutorials, documentation, everything like that online. You can try and make contact with the New Zealand community or the Australian community. A lot of us have done OpenLI. We're happy to help, or use someone to deploy it if you need to. So now I'll just move on to actually how to actually make OpenLI do the useful stuff for an ISP. So every ISP is different. There's no correct way to run an ISP. And for that reason, there's no standard way to deploy OpenLI. You can put all of the different components for OpenLI anywhere in your network that makes sense. And that's what I'm going to sort of go through now. So in terms of the ETSI standards, there's two different parts that make up a intercept. There is CCs or communication contents, and that's normally your IP data, or if it's voice, it'll be your RTP data. And then there's also IRIs, that's intercept related information, so your metadata. So with a data intercept, that's normally radius, and with a voice intercept, that is normally SIP. And the other sort of final part of a LI is to transport that data to a law enforcement agency. That could be done over a WAN or a VPN, or maybe if sort of the country allows it, that could be rolling PCAPs on a SFTP server or something like that. Ideally not that one, but it does happen. So the software itself is free. It runs on commodity hardware under Linux. And if you need it or want it, there is commercial support available at a relatively low cost. So these are the different sort of, or the infrastructure that you'll need for OpenLI. You'll need to deploy at least one provisioner, and that's normally virtual. You'll need a mediator to stream the data to a law enforcement agency. That's generally virtual, but in some cases you might want to have a real box for that. That mediator might need a public IP if it's going to terminate a VPN. It could have a separate file in front of it if you're going to do your VPN in that way, or it might be on a private WAN link for communicating with the law enforcement agencies. For the collector, you'll probably need at least one physical collector, maybe running DPDK, but there's also various ways to deploy a collector on a sort of virtual kind of hybrid way, which I'll touch upon shortly. So I'm not going to sort of go into too much detail on each one. This is all on the wiki, but I'm going to highlight a few points on each component of OpenLI that's things I've learned the hard way that you really should do just on day one. So you can basically install a provisioner as per the wiki, but bolded here is that you should enable TLS, because encrypting your data between the components when you're snooping data that's like private data is really important. It's really worthwhile setting up a law enforcement agency called localhost, and I'll touch on that when we get to our testing section a little bit later. And also there's a law enforcement agency which Shane calls PCAP disk. That's another really handy one to actually set up on your provisioner. Moving on to a mediator. In New Zealand, you pretty much just need one mediator to hand everything over to the authorities. However, some countries are a little bit bigger than New Zealand, so you might have some different requirements. You might need to have different mediators for different authorities, and OpenLI absolutely supports that. So again, install it as per the wiki. The key thing here I find is to set up a folder as your PCAP folder, pay attention to the permissions and change routing it and how that might work with an FTP server and everything like that if you need that. And the other thing is to actually install libtrace tools, which Shane also was sort of very involved in writing. And I'll show you why in our testing section later on. So to deploy a collector, or first of all, what's deployed on? Do you need a physical box? Like if your broadband is fast, so I'm talking hundreds of megabits, maybe into the gigabit or so, you probably do need a physical box with a 10 gig DPTK NIC. When you're installing it, install DPTK, instructions on the wiki, install OpenLI collector. But I'll talk shortly about different ways you can deploy collectors and different ways they could be very useful. So you know how to install it. You know how to install it. You can make them communicate with each other via a VRF or a VLAN or something like that. But how do you actually make this all work? Okay, recap. So you got CCs, your data, and you got IRIs, which is your kind of metadata. So for a data intercept, that's IP data and radius. So you've got, this is a really simplified ISP here, but you've got users and they talk to a BNG. So how do you get those packets into a collector? So you need to tell those packets to come out of the BNG into the collector. And the way you do that is by activating an intercept on that BNG. So with Juniper, you'll need a FlowTap Lite feature turned on and an SSP license, and you activate that using radius. With Nokia, that is config-based. Interestingly, you can either write that config or not write that config to disk for fairly obvious reasons. Some of those will survive reboots and some of them won't. With Cisco, you can turn it on via radius COA again or SNMP. And also to activate a intercept, you'll need to turn it on the provisioner, like actually provision that. And you can do that via config, or you can use the REST API that Shane has written. So you might have an ISP, like smaller ISPs or WISPs or something like that, wireless ISPs. You might have a static IP kind of setup. So you've got many users connected to a VLAN with a gateway. So how do you get those packets into the collector? So again, I normally sort of just say you can either snoop them in the middle and bring that data into the collector. You can bring in more data into the collector than just one user. The collector will have the job of just getting it down to that one user the authorities actually care about. Or again, you could actually do that snooping on your gateway and just having something mirroring that gateway kind of data into a collector. And as I touched on before, because you've got TZSP support, if you're a MikroTik network, you can actually just use TZSP to stream that data to a collector. So with the static IP intercept, you activate it by enabling your tap, and then you'd also enable your intercept on the provisioner. So what makes up a LI for an ISP? We've dealt with the data, and now we'll move on to the radius. Now, this is something where my technique has sort of changed over the many deployments I've done. So again, this is a really simplified ISP kind of shown here. You've got users, they talk to a BNG, the BNG uses a radius server. So my first approach was just find a tap anywhere on the network between the BNG and the radius server, and just bring that data into the collector. And that gets all your radius packets into the collector, job done. However, a lot of us actually run our radius infrastructure on a Linux system of some kind. And OpenLI also runs on a Linux system or it can run on Linux. So the sort of methodology I came up with is to actually install your collector software, because you can have many collectors, onto your radius server. Tell it to snoop the NIC that all the radius requests come in, and voila, you've got all the data coming into the collector. The problem with this is anyone that has access to that radius server can actually tell if an LI is happening by reading the syslog, so which maybe isn't ideal. So then we sort of came up with this sort of next approach, which is to have a secret radius server and your normal radius server. So you either tell your normal radius server to mirror everything to your secret one, or tell your BNG to mirror all the radius records, accounting records to the secret one. And sort of thus you can have a radius server that only kind of top-notch security cleared NOC staff have access to, that is the one that actually does the interception part of this. So really, there's many different ways to get radius into a collector. It will just depend on what your current setup looks like and what your secrecy requirements are, either within your ISP or maybe your country might dictate what you can do and can't do here. Okay, so moving on to voice. So I think most of us know if you've got users talking to an SBC or a SIP server, you've got SIP and you've got RTP. Relating this back to lawful intercept terms, your SIP is your IRI, your metadata, and your RTP is your communications content, your actual data. So again, my initial approach, the first few deployments, was to snoop this in the middle and get it into a collector, and your job is pretty much done. And again, you can take more than just the user of interest into that. The LI system will just get that down to the one user that you actually want to look at. But however, sort of much like Radius, SBCs or SIP servers are often Linux-based. So if you have one or many SBCs that are Linux-based, what you can do is just install the OpenLI collector on your SBC and tell it about the NIC that the useful data comes in on, and your job is done. So testing, you've installed everything, should be all good, right? Job done. But no, you've got to really test this, because when you get server to warrant, you really want to know that you can turn that on. You might have to turn that on within an hour or two, depending on what's gone on. So this is where we came back to my sort of tidbits I had in my install slides. So first of all, you can tell your provisioner to start using an LEA called PCAP disk, and that will just start writing PCAPs to a folder. So you can have a test user, turn on an LI for them, and you should see their data showing up in PCAPs. Open that with Wireshark, and you know it's good. But that doesn't show you that Etsy is working, because Etsy is sort of a very different system. So with that, you can install the libtrace tools that Shane has written on the mediator. You can set up a test law enforcement agency called localhost. And then you can run the commands I've got on the slide here, and that will then show you in a human readable way both the data coming in as well as the metadata coming in. And when you see a DNS request come in plain text, then you actually sort of see what someone's browsing to and things like that. When you start giving that data to a law enforcement agency, you normally would have a VPN or a private WAN involved. And sometimes that adds complexity because you've got outside IPs and inside IPs and everything like that. So again, I'd highly recommend to actually have a remote VM or similar that you control. Set up an IPsec VPN or similar to that. Stream your Etsy over that. You'll probably hit some issues, work out how to solve them, set up your you might need a bridge or a loopback device or similar, and just test that works. It's so much easier to test this in your own environment than testing it with the police or similar, or testing it in a high kind of pressure situation. We've got 2 hours to get a intercept turned on. Okay, so this is a sort of what an ISP might look like when it's got OpenLI fully deployed. And for this, we might want a laser pointer. So to start, we've got a very standard POP up in the top left here. And this is one where, like it's a fully fledged POP, you've got your own radius server locally to it, you've got your BNG there, and you can actually afford, or you've got the physical space to put a physical collector in that POP. So you're just connecting a 10 gig or whatever interface from the BNG into the collector, and that POP is dealt with. You've got a SIP server there, where this is a Linux-based SIP service. We're running the collector on top of it. You've got your provisioner up there that is just doing all the kind of configuration and telling all the components how to work. We've got an identical POP on the right-hand side. So this is, again, a standard POP. We've got lots of physical space, lots of power. We can run a collector on it. But what I wanted to show down the bottom left here is this is a POP where it's either smaller or we don't want to spend the money on a collector. You can very much take the packets out of a BNG, pop them into a layer 3 VPN or a VRF, and then pop them to a remote collector. You don't have to have a collector in every POP if it suits your network design. And then finally, down on the bottom here, we've got a mediator that is, of course, streaming over some sort of medium, internet or a WAN to a law enforcement agency. And that's sort of a typical kind of OpenLI architecture. Okay, so to finish off, a little bit about the current state of OpenLI. So unfortunately, recently, the University of Waikato has withdrawn their interest in OpenLI as an active project. The University of Waikato is still honouring all commercial support agreements, and they're using Shane for that. And what that means is OpenLI is looking for a new home to support its sort of ongoing code, maintenance, and improvement. And what we're hoping to do is at NZNOG in March, in about 3 weeks' time in New Zealand, we hope there'll be an announcement on the sort of future home of OpenLI. So if you need commercial support for OpenLI, there are contracts available. They are start from the thousands of New Zealand dollars and go up to sort of around that 10K mark. You don't need to take one of these. This is entirely optional. There will be, there's no public knowledge on what entity will offer that down the track, but there will be an entity down the track offering that same service. So in the Asia Pacific, we're really keen to see if we can provide value in the Asia Pacific region. We've actually received a grant from ISIF recently targeting Pacific countries. We're very interested in the small to medium networks. They're the ones that sort of really benefit from OpenLI rather than a true commercial solution. However, there's sort of very little information publicly available about LI around the world. I was sort of Googling about the Philippines a bit before and didn't find out too much. So we're just really interested in talking to law enforcement contacts, ISP contacts, anyone that can tell us how LI works in their part of the world and how we might be able to help with that, whether ETSI is useful, whether PCAP's useful, whether there's something else that we're missing that could be useful there. So we're really just sort of learning as we go. So yeah, final word, find me at breaks or this evening if you sort of want to talk about OpenLI or if it's something that could be useful to you. Talk to your colleagues, share knowledge, talk to New Zealanders about OpenLI. We've all kind of tended to use it and deployed it because we have to. And yeah, any questions from the audience? And now Shane's also in the virtual audience if you throw tricky ones that I can't actually answer. No questions. So yeah, find me at the break if there's anything. Thank you.
Thanks, Dave. So I think it's last conference day, a little bit of fatigue, no questions. But certainly considering, you know, LI is the Fight Club, don't talk about Fight Club. I think definitely worthwhile finding Dave in the hallways if you have any questions. That is it for today's session. So thank you.
Recording stopped.
It's our love, you know. It's our love. From I and I to everyone. Got to help. Well, we got to help, yeah. There's no need to cry, yeah. Got to help. Well, we got to help, yeah. Got to live that love. You know what I'm talking about? Come on.